Hi, I'm Rob. Welcome to Math Antics. Have you ever heard people use numbers like that? 1 times 10 to the 6th, or maybe 3.4 times 10 to the negative 8th? Well, those are examples of a way of writing numbers called scientific notation. That didn't sound quite right. Let me try that again. Scientific notation. Yes, that's better. Numbers can be really big or really small, right? Like, if you wanted to count up all of the cells that make up your body, it would be a really big number, something like 35 trillion cells. But if you wanted to measure the diameter of one of those cells using meters, you'd get a really small number, something like 0.0000005 meters. Not only are really big or small numbers a lot of work to write down because of all the zeros, they're hard to quickly evaluate and compare. At a glance, it's not easy to tell just how many number places there are in these really big or small numbers. And that's where scientific notation can really help us out. Instead of using a long sequence of decimal digits to represent numbers, scientific notation uses a shorter number multiplied by a power of 10. And it's always in that form, some number times 10 to the some exponent. Here's an example of a really long number, 125 million. And here's the equivalent number written in scientific notation, 1.25 times 10 to the 8th. This number is really small, 0.0000095. It's much less than 1, but it's not 0. And here's the same number written in scientific notation. Again, it consists of a number that has only one digit to the left of the decimal point, which is being multiplied by 10 to a certain power. But do you notice anything different about the exponent? Yep, it's negative. So what does that mean? Well, the short answer is that positive exponents show repeated multiplication, while negative exponents show repeated division. And since this is a negative exponent with 10 as the base, it means to repeatedly divide by 10. So now that you've seen how scientific notation works, and you realize that it's just a shorthand way of writing really big or really small numbers, let's break down the procedure for converting back and forth between numbers written in regular form and scientific notation. Starting with these two examples in regular form, first count how many number places you would need to shift the decimal point for there to be only one digit to the left of it. For this number, we would need to shift 8 places, and for this number, 6 places. The number of places you need to shift will be the exponent in the scientific notation form, but the sign of that exponent is determined by the direction you shifted. If you shifted to the left because you started with a big number, then the exponent will be positive. But if you shifted to the right because you started with a small number, then the exponent will be negative. So that gives you the times 10 to the something part of the scientific notation. And to get the number that's multiplied by that power of 10, you just take the shifted decimal number and remove any zeros that don't really need to be shown. There, that wasn't too hard, was it? But what if we start out with numbers that are in scientific notation and want to convert them into regular form? Let's do that with these two examples. The first step is to look at the exponent, which is the order of magnitude of the number. It tells you how many 10s you'll need to multiply or divide by to get the number in regular form. If the exponent is positive, it means that you'll need to multiply by that many 10s. In this example, that means that we would need to multiply by a total of 7 10s to get the number in regular form. That would be a lot of work, but we can also just shift the decimal point that number of places. Which direction do we need to shift it? Well, since we're multiplying by factors of 10, we need to shift it in the direction that will make the number bigger. That is, we need to shift it to the right. So we'll just shift the decimal point 7 places to the right. But as you can see, there aren't 7 digits after the decimal. So any places that don't have a digit will just be filled with a 0. There, our number in regular form is 41,650,000. In the second example, the exponent is negative, which means that we'll need to divide by that number of 10s to get the number in regular form. Again, we could just do that division, or we can shift the decimal point to save time. Since dividing by factors of 10 make a number smaller, we'll need to shift the decimal point in the direction that results in a smaller number, that is, to the left. Since our exponent is -5, we'll shift the decimal point 5 places to the left. And any places that we shift past that don't already have a digit in them will get filled with a 0. We'll also put a 0 in the ones place since that's always good form for decimal numbers. There, our number in regular form is 0.0000109. All right, that's the basics of scientific notation. It may seem a little confusing at first, but as you get more experience with it, it makes a lot of sense. And when it comes to writing really big or really small numbers, it's totally worth it. And even if you understand how scientific notation works, it may take some practice to get good at converting back and forth between it and regular form. So be sure to practice on your own. As always, thanks for watching Mathantics, and I'll see you next time. Learn more at mathantics.com.